So hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It's a good problem. It says a distance of nearest cell having 1. So we are given a binary grid where each cell contains 0 or 1. Find the distance of nearest one for a given cell in the grid. And this is how the distance is measured. So, and it is guaranteed that there is at least one cell with a value 1 in the grid. And we need to have a minimum distance and which we wanted to return. That's interesting. So it is very similar to the rotten oranges problem, I guess, from lead code. And if you know that, you can go ahead directly to the solution and you can apply it. It's not much a rocket science. But here the idea is to understand how far a self of 1 is from the cell with a value 0. So you see, I'll also zoom it a bit. For this 0, you see we have 1, 1 and 1, 2. We have multiple all these sources where we can have for 0, 0, we can have value as 1. We can also have value as 2 because we can anyway go from 0, 0 to 0, 2 or 0, 0 to 1, 1. But anyways, this is farther. Again, if we count this into picture, 2, 2, it would be way farther. It would be a distance of 4, which we don't want. We want minimum. So there are two possible ways. One thing is we can consider distance from 0 to 1 or 1 to 0. Whatever sounds better, that should be done. Now, logically thinking, what should be our topmost priority? So let's see what deterministic values we have. We are sure that if this grid has ij is equal to 1, then the distance of ij, I will say, equal to 0, because we are sure. Then we can say that, hey, I plus 1 and j can be 0 plus 1. If I plus 1 and j is not equal to 1, then only, else it would be 0. So similarly, if I would go I to j plus 1, it would be also 0 plus 1, correct? Because right now I'm at 0 and I'm taking one step towards j or one step towards I. So that is how I'm counting one step. So it would make sense for us to go from 1s to 0. That means deterministic sources to rest all areas. So now we are clear that we can go from 1 to 0. Now we know that in this between, if we are going from x to y, then the distance of y is equal to 1 plus the distance of x. Nothing rocket science, something which we have made point as made this point as well. I plus 1 is equal to 0 plus 1, whereas 0 is ij, distance of ij. Now we are at a point where it can happen. Let's assume I am at 1, 1 or I am at 1, 2. I am going away right, I'm going up, left, and then down. I'm reaching again the same point. So it means I was having a distance as 0, then I took step 1, step 2, step 3, and step 4. Do I want to update it by 4? Because we don't want, right? We want minimum value. So At this point, if we are getting the distance of the current location as greater, it's a sign that we are hitting a loop. How loop is generated? So from this a circle, or from this a circle, circle, circle. So that is how we are hitting a loop, and we don't want to get trapped. Hence, let's not proceed and continue with the next one. That's nice. That's nice. That is very good. So now we have a way how we can identify we are not within the loop. We identify a way to have a distance calculated from our previous distance. What is stopping us? So, well, the thing which is stopping us right now, or the thing which we are yet to decide upon, how should we proceed? Should we proceed step by step? That by that I mean, so from 1, I would try to go to what? From 0, 0, I would try to go to 1, 0, 0, 1, and 1, 1, or else I will try to go from 0, 0, 0, 1, 0, 2, 0, 3, and so on. So this boils down, what path should we choose, whether it is BFS or DFS. That's a question, and that's a very good question, by the way, because when you go DFS, say, then we cling to one source and then proceed. That might not be a case very often, and this would lead to major depths, which we don't want. We want to keep updating based upon the source. So we don't want to go away from the source, but we want it to be near to the source. Why we want it to be near to source? Because we wanted to go have a minimum distance. We wanted to have a minimum distance, and we are going from 1 to 0, 1 being our source. So that's in mind, we have to take an approach of BFS. That's nice. So what is stopping us? Let's jump into the code then. So they want us array of array. Let's use this, and here would be the distance residing. New array list, I'll say. Cool. And this, we would also have a final maximum value, which will be grid of 0 length multiplied by grid of 0 dot length. Note, ideally, if you are within an interview, you should first check whether grid is null or not. I am avoiding this right now just for the demonstration purposes. So for int, I'll take an array x from the grid, and what I'm doing is I'm populating the distance array initially. So populate the distance with maximum distance. Why maximum? Because right now we don't even know how far we wanted to go, and meanwhile I'll also then we will just go ahead and assume that we are at infinite distance from each other, because we have not yet discovered each other's. Hence, now I'm going to take int, or I'll take array list, integer of list, new array list. Now I'll take a final row size, I'll say, or just size would be suffice. X dot length. And now for int I is equal to 0, as less than plus plus is less than size plus plus, I'll add max. So this is a shortcut way where I'll just create a list and I'll populate max to it. I'll populate size limit of numbers, each containing max. So when we are out of this loop, we are sure that we are done with the distance matrix. Now we wanted to go ahead and identify our source, identify the source. So for that I'll just use a queue, because we are going to process this sources as well. Int, why I'm taking int, it would be clear. Source is build a new linked list, I'll say. And now for int I is equal to 0 is less than grid dot length I plus plus, and here for int j is equal to 0, j is less than grid dot length or grid of I dot length j plus plus. Now if grid of ij is not equal to 1, then continue, because as it's not source. Else what I'll do is source dot offer new int. Note, I'll take the positions are I comma j and 0. What is the 0? 0 is a distance, and as we know, the distance from 1 to 1 is 0, because 1 is standing at its own position. 1 is standing at its own position, so the distance from 1 to 1 is 0, which is correct, and this also is correct. Now we have identified the source. Now let's discover, or I'll say let's apply BFS. So now we know it. What I'll do is the source is empty, while the source is not empty. That means we have something going on with our source. Something is there within our source. I'll take out the source as current, source dot pole, and with this I know the coordinates. Current of 0, I'll get the x, y would be current of 1. If I can write this current, and the value would be current of 2. Now first of all we need to validate the index, so whether x, y are proper index or not. So if x is less than 0 or x is greater than or equal to grid dot length, or in any case y is less than 0 or y is greater than or equal to grid of x dot length, in such case continue. We don't want it to proceed further. Now check for any loops or check for any longer distances we captured. What does this mean? This simply means that, hey, if the value which we have v is greater than or equal to the current distance, so the current distance is just dot get x dot get y, and if it is, we are within a loop. Let's not go further and let's continue to the next one. Now if we are not, then what I'll do is distance dot get x dot set on y index. I'll set the value as v, because obviously if we are here, that means the value of v is lesser, and we wanted to get lesser distances or minimal distances. Now comes the part where we wanted to go further. Now explore the possibilities. What are the possibilities where we can go from xy coordinate? We can go of a new int. We can go to x from xy. If you are taking any step, it would be v plus 1. And what steps we can take? We can either go up, or we can go down. We can go either or left, or we can go either right. So these are the steps we can take. Obviously no diagonal movements are allowed. Then this works fine. So far so good. It looks nice, and we are bit by bit populating the distance array as well. Ultimately we will return the distance. Let's compile this for any compiler errors. It's taking a good amount of time. Okay, it's not a dynamically typed language, so it's an int, which I forgot to mention. So we have a max. Why we have a max? Because we wanted to populate it with the maximum value which we can have. Okay, now it says array index out of bound. That's interesting. Different errors every time. Length 0. Preconditions. Oh nice, oh nice. So apparently I have came to know that we have a list, but we have never populated the list into the distance. So this dot add list, that was a huge blunder. And now let's check. Nice, it has ran for the sample test cases. Let me submit this one. So this was just about BFS. Expected time complexity is, yeah, we have n into m, and auxiliary space, it took n into m. I'm not accounting for the distance, it was a result, hence the auxiliary space was more like a q space, as it might happen that every element within the array within the matrix is 1, and the topic tags are quite interesting here. It is, so we have submitted this, it has ran. The topic tags are PFS graph algorithm, so it's a kind of graph, adjacency matrix graph, which we have tried to create. So this was all about it. If you wanted to see more such kind of content, click the video on your right, and I'll see you in the next one.